Good evening, everyone. Am I audible?
Yes, ma'am.
Okay. So, how was the quiz one? Easy, moderate, difficult? You did well. Okay. Okay, so yeah.
In the quiz one, my marks was not so good. So, if I appear for the quiz two, then will it is it like only the quiz two marks will be considered?
You are asking if quiz one score is less, will quiz two will be considered. Is that correct?
Yes.
It's not like that. So usually you check the T-score formula. So if you check the T-score formula, depending on your scores, whatever score, I don't remember it exactly. Just give me a minute. I'll open the grading policy. Yeah. So in the T-score formula, you see that so the maximum of quiz 1 or quiz 2 will be considered. Okay, so that is one part of the score, and also 0.25% of quiz 1 and 0.3% of quiz 2 will be considered in another part of the formula. So anyway, quiz 1 will contribute to your overall T score, but quiz 2 contributes more compared to quiz 1. Okay.
Okay.
All right, so let's move into week 5. So far from week 1 to 4, we were seeing concepts like mainly about statistics, populations, and then sample, and then how to understand this given statistical study using descriptive statistics. What is descriptive statistics? What are the different central tendencies, measures of variation? So these things we have seen so far from week 1 to 4. Okay. So now we are moving to a different topic called permutations. Okay. So in this week, particularly, we are going to concentrate on the following topics. So basic principles of counting, factorials, permutations when objects are distinct. So here, repetitions not allowed and repetitions allowed. Two different subparts are there in this. And then permutation when objects are not distinct. And then we are going to look at circular permutations. So in circular permutations, again, you have two different categories when you have clockwise and anti-clockwise are different and same. And at last, we will be solving some permutation formula for finding R and N. So these are the topics we are going to cover in today's session. Okay. All right. So we'll start with very simple question. It will be good if you all can participate because they are very basic questions only. Try to answer whatever you feel is the answer. Try to answer the questions. Okay. Read these questions. You have a coupon from a cafe that allows you to get one item, either a muffin or a milkshake. Okay. So the following are the available choices for you. You have three different options of muffins, blueberry, choco, and strawberry. And in milkshake, you have two options, chocolate milkshake and strawberry milkshake. So you have all these options, but your coupon allows you to choose either a muffin or a milkshake out of all this. So in this, what do you think about the number of ways you can choose your coupon?
Right.
5.
6
Very
ways.
yeah, very obvious, right? Because you have three options here and then you have two options here. So the answer is 3 plus 2. We have 5 options, right? Okay. So this is a very straightforward question. So there are 5 different ways to use the coupon. So this is the simple addition rule of counting. So if an action A can occur in N1 different ways, another action B can occur in N2 different ways, then the total number of occurrence of the actions of A or B is N1 plus N2. Okay. Now, suppose, look at the next question. Suppose the coupon allows you to get one muffin and one milkshake. Suppose we have 3 muffins and 2 milkshake. How many sets can we make?
6.
Yes. Right? So when you have blueberry, you see with blueberry, you have the combination of either a chocolate milkshake or a strawberry milkshake. Again, with strawberry muffin, you have again these two combination. Again, with choco muffin, you have again these two combination. Right? So in each case, you see that you have two different combinations of milkshake, and hence you see that totally 6 combinations are there. So these are the 6 combinations. Right? So here, what is your N1? Your N1 is 3, your N2 is 2, and your total possible sets is N1 into N2, so 6. Right? Okay. So how to understand this based on tree diagrams? So the same concept, this is a very small problem, so it is very straightforward. But suppose we are having bigger numbers, so just to understand it in a better way, we are trying to see it in multiple ways. Okay, so the other ways looking at this kind of a tree diagrams. So here you see that, suppose you have, so here this is, let's call this a blueberry muffin. Okay, and then you have strawberry muffin, and then you have choco muffin. So these are the different muffins you are having, right? And then you are having different milkshakes, right? So you have strawberry milkshake, you have choco milkshake. So with each muffin, you have this possible combinations of milkshake, strawberry milkshake or choco milkshake. So these are the possible options, right? So how many options you see here? So this is 1. So this combination is, so by 1, I mean, so here 1 means blueberry muffin and strawberry milkshake. So this is 2, this is 3, this is 4, this is 5, this is 6. So what is the 5th option? Can you tell? What is the 5th option here from this tree graph?
Choco muffin and the strawberry milkshake.
Yeah. Okay. So this is another way to understand what are the different possible options. Okay. So now what is the general multiplication rule of counting? If an action A can occur in N1 different ways, another action B can occur in N2 different ways, then the total number of occurrence of the actions A and B together is N1 into N2. Okay. Okay. Now we have another item added to it. Now read the question. Suppose the coupon that allows you to get one muffin, one milkshake, and one fried snacks. Suppose we have 3 muffins, 2 milkshakes, and 3 snacks. How many sets can we make?
18.
18, right? So in this case, what is your N1? Your N1 is 3, N2 is 2, your N3 is 3. So your answer should be N1 into N1 in N2 into N3. So 3 into 2 into 3. So 6 into 3, 18. Right? And what are those sets? So here first we have 3 different muffins. Right? And milkshakes, you have again 2 different milkshakes. And snacks, you are having 3 snacks. So let us just call the snacks as some S1, S2, S3. Alright. So these are possible combinations. So now how many combinations we can observe here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. For example, can you tell what is the 14th choice here? What is the 14th choice you see?
Milk muffin, a strawberry milkshake, and snack food.
Yeah. Okay. So this is how you see what is the specific combination you see. Okay. Fine. So now generalizing this. So if a task is done in R steps and there are Ni ways to perform the ith step, then the total number of ways to complete the task is N1 into N2 into up to Nr. Okay, so you can keep on multiplying this. So even if there are R steps, you can still do the same technique. Okay, so now let's look at another example here. So we want to create alphanumeric code. Suppose you are asked to create a 6-digit alphanumeric password with the following requirement. The password should have first two should have capital letters. So how many capital letters are there in English?
26.
26, right? So you have from options are from A to Z, right? For the first two letters, followed by 4 numbers. So 4 numbers means it can be any number. So what are the different possible numbers you can put in any place in any of this
0
4?
to 9.
0 to 9. Right? So for the first option, number of ways here, you see 26 possible ways, and here again second 26. And in fourth position, how many possible, third position, 10.
10.
Fourth,
10.
fourth is,
Ma'am, can I ask a question?
yes,
Ma'am, will the week 5 deadline not be postponed?
no.
Okay,
Okay.
ma'am. Thank you.
Yes, so here for the fourth position, again, how many possible options are there?
10.
10.
10, because here it is given that repetition is allowed. That's why 10 possibilities. Again, in the fifth position, number of possibilities. Come on, 10.
10.
And last one,
10.
10. You can verify if you multiply, this is the answer you will be getting. Okay, verify whether you are getting the same answer. Okay, now this is when repetition is not, repetition is allowed. Now what happens when the repetition is not allowed? Okay, so if the repetition is not allowed, so first one usually don't have any problem. So first one, the number of options will remain the same. What will happen to the second one?
1
25.
less.
One less.
25.
Yeah. Okay. Now again, the first position here will not be affected. You will have all possible values from 0 to 9. So how many values are possible here?
10.
10.
10. And now what about the next one?
9.
9.
And then
8.
8.
7.
7.
7. Right? So you can verify whether you are getting the following answer if you do the multiplication. Okay, fine. So this is a very simple problem. So similarly, let's look at another problem here. There are 3 athletes who take part in a 100-meter race. What are the possible ways the athlete can finish the race? Assume there are no ties. Okay. So the 3 athletes, let A1, A2, and A3 be the 3 athletes. If they are the 3 athletes, now we have 3 positions also. What are the possible ways the athletes can finish the race? Okay, so
27.
yes. 27. Okay, so why 27? I just said yes, but it's not correct. I want to know why 27.
Like NP to our R, that concept.
One
See,
position,
27.
one man can't hold all 3 positions.
See, that is a different concept. Let's see, first of all, let's try to understand. See, these three athletes, if they are running, so there can be only three positions, right? So first, second, and third, only three positions can be there. So what are the different combinations? So first of all, if A1 comes first, then either you have this possibility or this possibility, right? Or if A2 comes first, then again you have these two possibilities. Or if A3 comes first, then again you have these two possibilities. Are there any other possibilities?
No.
No, right? So here you see you have only 6 different options, right? So you see 6 ways. And how are these 6 ways you can understand? So in the first position, so for the first position, so you have any of the 3 can come, right? Any of the 3 can come. And in the second position, already if one person has attained the first position, then for second position, how many possible person are there in second position?
So,
2. And in third,
1.
1. Right? So totally 6 possible ways. Okay. So here, this is again a problem similar to the previous problem, right? Now, the same scenario you can do for any number of athletes. There are 8 athletes who take part in the in a similar race. What are the possible ways the athletes can finish the race assuming no times? Again, first place any one of the 8 athletes. Second, any of the 7. So in this way, if you do the total number of ways, what is it you can understand? 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Right? The same way you understood this problem. Right? So up to this, is this clear?
Yes, ma'am.
Okay. So now we need a common notation to simplify the way we answer these questions. For this, we are introducing factorial, right? So factorial means the product of the first n positive integers is called n factorial and is denoted by this symbol. Okay, n with followed by an exclamation, right? So n factorial means n into n minus 1 into so on up to 1, right? So in this way, so what can you say about this one? This is simply
3 factorial.
3 factorial. And what about this one?
8 factorial.
8 factorial, right? Okay. What is 0 factorial means? So 0 factorial, in general, we are defining it to be 1. Okay, so this is a convention. There is no specific way to, you should try to understand this. This is just a convention. This is how it is defined. Okay, so you see, for example, 5 factorial is this, and 5 factorial can be simplified in this way. So few relation between this factorials, we just need it for some problems in later on. Okay, so you see 5 factorial means 5 into 4 into 3 into 2 into 1. And this part you see is just 4 factorial. So I can write it as 5 into 4 factorial. And this is true for any n factorial. So n factorial is equal to n into n minus 1 factorial. Okay. So same way you can keep on simplifying this. Again, this 4 factorial, you can write it as 4 into 3 factorial. Same way you can keep on reducing again and again. So in general, the formula can be written in this way. So for I less equal to n factorial is n into n minus 1 into and so on, n minus I factorial. Okay, remember your I should be less than or equal to n. Okay, fine. So up to this, what have we seen? So we have seen, so suppose you are having 2 different objects, but out of 2 different objects, you have only one choice. So in that case, you simply add them up, n1 into n1 plus n2, right? So either this or that means you simply add them, n1 plus n2. So if you have more than 2, then also you do n1 plus n2 plus n3 and so on, right? And suppose you are looking at combinations, then what you do? You do n1 into n2 into n3 and so on. You do the multiplication, right? And then what you have seen? So you have seen this kind of things. So here, suppose you see the same concept only, but here when repetitions are not allowed, you have to reduce the a number of options when you go to the next stage, right? So this is another part we have seen. And when you have distinct objects and the position here matters, then you see that you are looking at factorials, right? Okay, so these are different concepts we have seen so far. Okay, now what is mean
Ma'am,
by
I have a question.
yeah,
Can you just go up, ma'am?
yeah.
Yeah, this one, the third one. Like
Hmm.
the formula.
This one, right?
No, the formula, ma'am. Can you scroll down?
Okay.
Down. Yeah, the third. After the third observation, in general, for I less than n, we have n factorial. Can you explain that one, ma'am? I
Okay,
couldn't.
I can compare it with the third one here. For example, so here, let's say, here your n is 5, right? So what is n minus 1 for the previous term? So n minus 1 is 4. Okay. So now what is my n minus I? Suppose I want to compare 3 factorial with n minus I factorial. So it means I am comparing 3 with n minus I. So what is my I here? N is 5. So what should be my I? My I is
2.
Tell me what is your I? I is 2, right? So in this case, your n factorial is simply n into n minus 1 into n minus here I factorial, where your I is nothing but 2. Okay, so in this case, your I is 2. Okay, so if suppose you are going to take I is equal to 3, then what will happen? Suppose you are going to take I is equal to 3. Then what will happen? So you have n factorial is equal to n into n minus 1 into, so here for example, in the case of 5 factorial, it will be 5 into 4 into, so here this is n minus I plus 1. So what is this I plus 1? So I is 3. So I is 3 means n minus I plus 3 will be n minus 2, which is again 3, right? Now again here, this is n minus I factorial. So this is 2 factorial. Now do you understand? And in the previous case, you can note that what is n minus I plus 1? N minus I plus 1 is 5 minus 2 plus 1. So it is same as 5 minus 1, which is matching with n minus 1. So in this
Okay.
case, your n minus I plus 1 happens to be n minus 1. Now you
Okay.
understand?
Yes,
Okay.
ma'am. Thank you.
Okay. Okay. What are permutations? Okay. So now the definition of permutation is as follows. A permutation is an ordered arrangement of all or some of n objects. This word ordered is very important. So for permutation means it is always ordered arrangement. So ordered arrangement is what is the word very important here. Permutation, always remember it is ordered. Okay, fine. Now let's look at this question here. So if 3 students stand in a line, how many different ways can they stand? Okay, here again let students be A, B and C. The different ways for them to stand is, can you say? What are the different ways they can stand? Just like we did the race thing, the same concept only. Here, instead of A1, A2, A3, now it's just ABC. Almost the same.
Yeah, it's the same 3 factorial.
Yes,
Sir, what?
CB.
ABC.
ACB,
ACB,
Yeah.
B.
BAC,
BAC,
BCA,
BCA,
Then
CA,
CAB,
CBA,
CBA,
so you have how many ways?
6.
6.
6 ways. Okay, so this is called a permutation, and here order matters. Okay, who is occupying which position matters, right? Okay, now let's look at another problem. Out of 5 students, how many ways can we select 3 and arrange them? So this is something similar to again what we saw earlier, right? The password problem. The first position you have 5 choices, second position 4 choices, and third position 3 choices, right? So you have 5 into 4 into 3 options. So what is the total 5 into 4 into 3?
60.
60.
60. Okay, so this is a question typical to what we call as permutation. So given n, so this is your n, out of n, how many possible ways we can arrange our items? Okay, so this is a typical permutation question. And for such questions, usually this is how we write the answer, n into n minus 1 into n minus r plus 1, which is denoted by this formula, NPR is equal to n factorial by n minus r factorial. Okay, so how to relate this again with this, whatever we have done? Okay, so what we have already as an answer is 5 into 4 into 3. Okay, now how I can relate it with the formula given below. So I'm going to multiply and divide with this part. Okay, so now what is the numerator here?
5 factorial.
And what is the denominator here?
2 factorial.
2 factorial, right? So here you see that n is equal to 5 and r is equal to 3. So here what is that you get? So this is nothing but n factorial by n minus r factorial. Okay, so you see how this 5 into 4 into 3 is same as n factorial by n minus r factorial.
In the denominator, how factorial 2 came?
I'm just multiplying and dividing by 2 into 1 for both numerator and denominator. So I'm this
Acha, okay.
got it?
Mm-hmm. Okay.
Oh. So you can see this formula is what we call as the permutation formula NPR. So n factorial by n minus r factorial. Okay, fine. Okay, so now let's see whether we can apply this formula in the following questions. How many ways can 4 friends sit in 4 chairs? So so try to identify what is your n and what is your r.
4 are 4 and the answer is 24.
So number of chairs should be your n, right?
N is also 4, yes.
And what is the number of friends here? Again, that is
4.
also
4.
right? So in this case, your NPR is 4 factorial by 4 minus 4 factorial, which is
4
4
factorial.
4
factorial and 24.
so it is simply 4 factorial, right? Because 0
24.
factorial, we know it is equal to 1. So it is simply 4 factorial, right? And this is if you have not seen the permutation formula, how you would have solved it? You would have said, okay, so you have 4 chairs. So first one, there are 4 possible ways. Second one, you have 3 possible ways. Third, 2 possible, 1. Right? So this is how you would have solved it. Right? Okay. Now, how many ways can we form a 3-letter password from ABCD? No repetition.
Here
So,
n is equal to 4.
4 and your
N
r
is
is
equal
equal
to
to
3.
3. Right? So you have n is
So
equal to
4
ABCD
3.
and 3-letter password. So
R
n,
would be always less than N, right?
yes, correct.
Yes.
So here you see that
So this
NPR
same
n
answer
4 factorial
is
by n minus r. So 1 factorial. 1 factorial is again 1. So again here also 4 factorial. And what is 4 factorial?
24.
24. Right? The usual way how you would have done this, you would have had 3 letters. So the first option you have like 4 different
Four
ways.
ways.
Second 3 because no repetition. And third one again 2. So which is same as again 4 factorial. Okay, fine. Okay, now let's look at the third example. How many ways can we choose 2 from 5 students? So these 2, we are going to choose one as a captain and another as a vice captain. Right? So for 2 different positions, we need people.
Here N is 5, R is 2.
Yeah, N is 5 and R is 2. So in that case, so N, P, R, so 5, P, 2. So what is 5P2? Calculate and tell me.
5
It is
factorial by
20.
3 factorial.
So it is 5 into 4.
20.
Okay, fine.
Yes,
All right. So always remember permutation means some arrangement is there. It means order matters. Okay, specific type of arrangement, that is order matters there. Okay, fine. Okay, now from 5 students, how many ways can you select and arrange 0 students? What is mean by selecting and arranging 0 students? So how will you choose 0 students? It means you are not choosing anyone, right? So if you are not choosing anyone, is there anything to arrange? There is nothing to arrange, right? So it means how many ways you cannot arrange anything?
One.
Just one way, right? So this is what is NP0. So in this case, your R is simply 0. So what is NP0? NP0 is 1, right? Because what is NP0? N factorial by N factorial. So it's simply 1. Okay? Fine. Okay, now let's try to understand the next question. From 5 students, how many ways can you select and arrange one student? You can choose any one of the 5 students. This is you don't need permutation or anything. So you just want one student out of 5. So how many options you have? It's like a very first question.
5
Even simpler
students.
than that. Yeah, just 5 ways. Right? So again, comparing with the permutation formula. So here N is 5 and R is 1. So what is your NPR? So 5 factorial by 4 factorial. So which is 5. And in general, you can see that NP N minus 1. Sorry, NP1. What is NP1 in general?
N.
N. Right? Because you see NP1 is N factorial by N minus 1 factorial. So it's equal to N. NP1 is N. Okay, fine. From 5 students, how many ways can you arrange 5 students? This also we have seen earlier. How many ways can we
120.
arrange?
120.
Yeah,
5 factorial.
exactly. Right. So here again N is 5, R is also 5. So NPR, which is 5P5. So what's happening here? 5 factorial by 0 factorial. So 5 factorial. Right. So again here you see NPN is N factorial. Okay. Similarly, NP0 is also N factorial. Okay. All right. So these are the special cases we have seen. So NP0 means 1, NP1 means N, NPN means N factorial. Okay. Sorry, NP0 is 1 I mentioned as N factorial, right? Sorry. NP0 means 1. Okay. And NP1 means N and NPN is N factorial. And we have seen different examples about to understand this. Okay. Okay. Can you try this yourself? Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5 if no digit is repeated.
Like n is 5 and r is 4.
Yes.
5 into 4 into 3 into 2, 120.
Factorial 5, 120.
Okay. So we have 5, 4, 3, 2,
So
8. Okay. Now the next part is a little tricky. You have to be careful. Not very tricky, but next level we are moving. How many of this will be even? Okay. What are even numbers?
ending with 2 or 2.
Yeah. So number is even if the last digit is so in our case we have only 1, 2, 3, 4, 5. So either 2
2
or 4. Right? Okay. So now you see this here again you have 4-digit number, right? For the 4-digit number, no digit is repeated, right? So, and also you want them to be even. So, even means either it should end with 2 or it should end with 4. So, suppose let's fix 2 here and let's fix another possible thing is I want to fix it as 4. Then what will happen? If I'm fixing this 2,
Here one place is
so how many
fixed,
options you
so
are, how many
Yes.
choices you are having here for first, all these 3 together?
We have to fill 3 places with 5 digits.
No, not 5.
4 digits.
Only 4 you are having.
Like
Right.
repetition is allowed, na? For 3 digits, we can pick 2 also.
No, no digit is repeated.
Oh, acha.
Okay, digits are not repeated. So in this case, how many are possible? 4, 3, 2.
Two.
Right? So 4 into 3 into 2 is 24. And here how many choices again? So 1, 2, 3, 5. These are the choices. Again, 4 choices only. So it's the same thing is, so this is not the number of options. So this is the number 2 and the number 4. Okay, so note that these are like fixed. Okay, and here also the same. So here also 24. So now this 24 and this 24. So together you have 24 plus 24. So how many options are possible now? 48. Okay, so you are
Ma'am,
using,
in
yes,
even number, like when we fix that number, so where existing the other number, we don't take that number again, right? Like if 2 is fixed one, so I won't we take 2 again.
yes, that's why I have written on the top the what are the possible choices 1, 3, 4, 5 because 2 is already taken. I have the remaining choices are only 1, 3, 4, 5. 2 is not going to appear again. So out of these 4 numbers, any one number will come in the first position. And then already another number is taken. So in the second position, only 3 options. Third position, again only 2 options. The same goes for the second scenario where the fixed number is 4. We have only 4 choices remaining because we are not considering 4 again. Is that clear?
Okay, ma'am. Got it. Yes, ma'am.
Okay. Okay. Read this carefully. The first one is a very easy, straightforward one only. You have 10 seats and 6 people. How many ways they can sit?
10 P6.
10 pieces. Right? Okay. What about the second part? All the empty seats are next to each other.
10p7,
Is
like
it why
uh
7?
7p6. Yeah.
The all empty
acha,
seats
acha, yes,
together.
6 seat, and all the remaining 4 empty seat
5.
would be considered a 1 seat.
Yeah. How
So
many empty seats will be there?
7p6, 4.
10p4.
4, right? So consider 4 seats as 1 seat. So total only 6 plus 1, 7 seats. Now in the 7 seats, you want to make 6 people sit. So how many possible ways? Now what's the answer?
7p6.
That's it, right? Is this question clear for everyone?
So,
Yeah?
Ma'am,
No.
can you explain the second one again?
Yes,
I couldn't
sure,
understand.
sure. See, what we have done here is that all the empty seats are next to each other. It means empty seats are going to be together. People are not going to leave any gaps in between. They are going to sit together only. Okay. So in that case, all the 4 seats I can consider as 1 seat. Yeah, the empty seats
Yes.
I can consider as 1 seat. So already you need 6 seat for these people to sit, and then this extra 4 seat which I have combined as 1 seat will be remaining, right? And so you see that, so 6 plus 1, 7 seats are the total possible positions for them to sit, right? And out of that, how many people have to be seated? 6 people have to be seated. So 7p6. So this is your n in this case. Your 6 r is already 6, that is fixed. Only the n has changed in this case. Is it clear or still not?
Yes, ma'am, it's clear.
Okay, fine. Yeah, any other questions? Okay. Now listen to this part very carefully. So this is a little bit different. So
Hello, ma'am.
yes, any questions?
Yes, ma'am. In previous question, why we are considering 4 seats as one?
Because they are going to, all these empty seats are going to be next to each other. It means they are going to be combined in one place. Okay, they are going to come. So maybe I will give you a simple example. So instead of considering like 7 and 10 and 6, let's say you are having 5 seats and 3 people have to be seated. Suppose this is the scenario, let's say. Okay. Now, suppose in this case, 2 seat is, the empty seats are always together, I am saying. So in that case, what I can do is that, so these empty seats, instead of considering them as 2 empty seats, I will consider consider it as 1 empty seat, because it's going to occur together only, wherever it is. Okay, so if it is going to occur here in the front, then also again I'm going to consider it together. So this one I'm not going to consider an individual part, because see, empty seats are coming together means there is no see, if this is empty, whatever I place here is not going to be affected by this empty seat, right? So whether this empty seat, interchanging, that is not happening here. So it is considered as one, means no change is happening. You understand why? If I consider this 2 seat as 1 seat, no change is happening. Do you understand that? Or still not able to understand? I can try to explain it in a different way if you are not able to understand. See, these are the only possible ways in which this kind of a seating is possible, right? So where the empty rows are together. Are there any other possible ways in which the empty rows can be together?
They can be in the middle also.
If they are in the middle, then what happens? Again,
The people cannot sit together, like there would be vacant place in the middle.
so again, in this case, if, okay, yeah, this is also possible. So now if this is the empty seat scenario, Again, if I'm going to split them as 2, what difference is it going to make? Suppose I'm calling this, for example, suppose I'm going to call this as E1, E2. 2 different slots, suppose I'm considering them. Is it going to make any change if it is E1, E2 or E2, E1? They are just empty slot and they are together. Is it going to
Yes.
make any change? There is no change in these 2
No,
slots.
no.
That
Correct.
is why instead of considering them as 2 different slots, whatever is this empty slot, I am considering it as 1 slot only. Okay? I am not going to consider it as individual slots. Okay, why I am considering it as 1 slot, is that clear?
Yes, ma'am.
Okay. So this kind of scenario will occur in several problems, so you should understand this very clearly. Okay? So this kind of scenario, sometimes you may have questions like 2 friends who always want to sit together, but that is different. Okay, why? Yeah, so 2 friends want to sit together means inside them, if they change position, the ordering will matter.
Internal real.
Yeah, so you have to be clearly understanding what is going on and why we are specifically here considering this 2 as 1. That should be very clear. Okay. So later on, you can compare with other scenarios also. What is the difference? You can compare with other questions. Okay. Fine. Okay. So now let's look at this question. Form 3-digit numbers using digits 1, 2, 3 with repetition allowed. So this is very important. Here, repetition is allowed. So if repetition is allowed and you have 3 positions, so here you have 3 positions. Right? So how many choices you are having? How many choices you are having?
27.
3 distinct choices you are having, right? And what is the, this is
Each
3.
digit will have 3 ways to put in one place.
Yeah. So what is the length we are going to consider here?
3.
3.
3. Right? So in the first position, how many options are there?
3.
3. Second?
3.
3. Third?
3.
Because repetition is allowed, everything is 3. So it is simply 3 power 3. So 27. So here repetition is allowed. That's why 3 power 3. So here we have done n power r. Okay. We have done n power r. Okay. Now the same. So here what is the number of choices?
2, ma'am.
Number of choices is 2.
2.
Okay. And what is the length we are considering?
3.
3.
Length is 3. Right? So here you see that you are having only 2 places to fill. And for the first place, how many choices you are having?
Ma'am, 3 places.
Oh, sorry, 3 places. 3 places. And first place, how many options you are having?
2.
3.
2
2
options. And second?
2.
2.
And third?
2.
2. So you have 2 into 2 into 2.
Cube.
So 2 cube. So this is
8.
8. So which is again n power r. Right? So now.
So ma'am, whenever like in the question it said like it's the repetition is allowed, so
Yeah.
we will use the n is to power r1 formula.
Yeah, you
Oh.
use this formula when the again here in this scenario, here order matters, right? So the number of permutations of length are formed from n distinct objects with repetition allowed as n into n into n and is denoted by n power r. So up to this, is this clear? How n power r we are applying here, is this clear? Because in both these scenarios, repetition is allowed. That's why the formula is now different. Is this clear?
Yes, sir.
I always get like confused between in this question when repetition is allowed. I always get confused between R and N. Like which one is N and which one is R. I get
That's
confused
why
with
I
that.
specifically wrote in both the options. So you always write n as write in this way. When you practice also write in this way. Instead of just writing n equal to 3, r equal to 3, write what is mean by n. N is number of choices. So here in this case, this represents your n. right? And this represents your R. Similarly, here this represents your N, number of choices you are having. And the length, the number of boxes. The length is kind of number of boxes if you want to understand. You can think it in this way also. If you remember it in this way, definitely you will not have confusion. Okay?
Okay.
Yeah. Okay. Now, the next question is a little bit different. Okay. Suppose we want to rearrange the letters in the word data. How many ways can it be done? So what is that we know? Okay. So totally, how many letters are there? How many choices are there?
4.
4.
Four. Yeah. 4 words, 4 boxes. So how many 4 places? How many ways we can do this simply? So,
Power of
4 factorial.
so you have data. So here, first option you have 4. Second you have 3. And second, because rearrangement means you are just going to use whatever is already there, right? So second is 1. So this is how you can do. Is that correct? Yeah.
Yes.
So 4 factorial ways. But there is something you need to take care here.
There are years repeated.
Yeah.
So,
Yeah.
so divided by
So,
2, I think.
yeah.
2
A
factorial.
is, yeah. A is appearing twice. So what we have done is that we have considered these two A as different letters. Then only we have 4 into 3 into 2 into 1, right? So what we have done, we have considered this A as some A1 and this A as some A2. Suppose let's say we have considered it in this way. Then what we have done, so we have said that D A1, A2, this is different from D A2, A1. This is how we have answered it as 4 factorial. But are they actually different?
No.
No, they are same, right? Similarly, if you are considering DA1, TA2, is it different from DA2, TA1?
No.
No. They are same. So it means what is that we are doing? So this A1 and A2, whatever arrangements happens between these two, that we are counting twice. Or the number of times, not just twice, the 2 factorial. The number of ways here, in this particular case, it is twice because it is just 2 factorial. But in general, the number of possible arrangements, whatever is there, that many times it is going extra. Right? So here, A1 and A2 can be arranged in how many ways? How many ways? 2 letters. So 4 letters, 4 factorial. So 2
factorial
letters,
ways.
2
2
factorial.
factorial ways.
That many times extra we have counted. So to reduce this 2 factorial from this 4 factorial, we have to divide it by 2 factorial. So this is the number of ways. Is this clear why we are dividing by 2 factorial?
Yes,
This many times it is occurring extra. Okay? That's why we are dividing by 2 factorial. Is this clear?
Yes, ma'am.
So now instead of the word data, suppose I want to consider the word statistics. Then what will you do? Consider the word statistics. Now you want to again do a similar rearrangement here. Now what will you do? So what is the total number of letters anyway here?
10.
10.
Total number of letters is 10. Right? Your N is 10. Okay. Now what are the distinct letters?
Distinct letters. S, P, A, I, C.
So how many times S is repeating?
3 times.
How many times T is repeating?
3 times.
How many times A is repeating?
1,
I,
2, 2,
C,
1.
So 3 plus 3 plus 1 plus 2 plus 1, 10. So we have counted everything correctly. Okay. Now, what do you think is the number of possible arrangements?
Factorial 10 upon factorial 3 into factorial 3 divided by 3 into 3 factorial into 2 factorial.
Yeah, so 10 factorial by 3 factorial into 3 factorial into 1 factorial. So 1 and 1 we can ignore. So just whatever is repeating we can divide. Why are we doing this? Is that clear for everyone? Again, the same thing will happen. So just this S, so it will be considered like S1, S2, S3 and we will be having several combinations. But inside this S1, S2, S3, how many possible combinations are possible? 3 factorial. So that we are dividing. Same way for T, again 3 factorial ways and again I 2 factorial. That's why 3 factorial, 3 factorial, 2 factorial. We are dividing. Is that clear?
Yes, ma'am.
Okay, fine. Okay, so the number of permutations of n objects when p of them are of one kind and the rest distinct is equal to, so in this case it is simply n factorial by p factorial. Okay, so number of permutations of n objects when p of them are of one kind and rest distinct is equal to n factorial by p factorial. Clear, right? Okay. So if you have several words which are repeating, then this is the formula you will use. Okay.
Yes, ma'am.
So far everything clear? Okay, fine. So now continuing further. So how many ways can 4 people sit around a round table? So we are moving to the next scenario. So listen to this part carefully. So now we are having 4 different people. So we call them, let's say A, B, C, and D. Okay. So the arrangements are, you can see A, B, C, D, B, C, D, A, C, D, A, B, and D, A, B, C. So these are different arrangements, right? There are more arrangements. Just we are considering this set first of all. Why specifically this set, you will understand now. So the first A, B, C, D, you see A, B, C, D, first A, and then B, and then C, and then D, right? Again, B, C, D, A. So if you consider B, C, D, A, again, who is the neighbor of B? Who is the neighbor of B? The neighbor
C.
of B is C and here A, right? So here the neighbors of A are D and B. Same way the neighbors of A are D and B only. Same way for C, who are the neighbors in the previous case, B and D. The scenario is the same. It's just rotated, right? So everything is just rotated. So here also you see, so this position is just shifted. Just one was just rotated. Imagine the table is kind of rotated. Then you see everything, the neighbors are same. So A, B, C, D, B, C, D, A, C, D, A, B, D, A, B, C. If you are consider them in a row, then these are different. But when you are arranging them in a round table, these positions are same. Do you understand why they are same? Why all are same? Is that clear for everyone? If not, please tell me, I'll repeat. Should I repeat?
Yeah, ma'am. Can you repeat?
Yes, ma'am.
Yeah, fine. I'll repeat. See, in this case, who are the neighbors of A in the first case?
B and D.
D and D. Who are the neighbors of B?
A and
A
C,
and C.
And who are the neighbors of C?
B and D,
B and D.
And who are the neighbors of D?
A and C,
A and C. Right? Okay. Now let's see the second one. Who are the neighbors of A?
B and D,
Who are the neighbors of B?
um, A and C,
Who are the neighbors of C?
B and D,
Who are the neighbors of D?
A and C.
So did anything change? it's better to follow the same order. So the neighbors of A are on the left D and on the right B. So nothing has changed, right? Only thing you can see that the A here has shifted to this position. So earlier A was here and now A has come here, right? In figure 1. So in figure 1, A was here and now A has shifted here. Similarly, D was here and D shifted here. And then C was here, C shifted here, and B was here, B shifted here. Just it's kind of a small rotation has happened, right? So the same thing has happened here. Now suppose let's call this figure 2. Now again a rotation has happened. So you see A was here in this figure. Now this has come here. And D was here. Sorry. Sorry. Yeah. Yeah, so D was here in figure 2, which moved to this position. Again, the things are just rotating. Nothing has changed. You see what is happening? The position is kind of just rotated. Nothing has changed. The neighbors are the same. You can observe the same in the next figure also. So if this is figure 3, so in figure 4, what has happened? So earlier this was the original position of A in figure 3, which moved here. And the original position of D was here, which moved here. And the position of C was here, which moved here. And D was here, which moved here. You understand what's happening? Everything is just rotated once. So the neighbors have not changed. So the arrangement is exactly the same. Nothing has changed. Okay? Is this clear? What has happened? Why they are same? Is that clear for everyone? The arrangement are not different. They are same. Is that clear for everyone?
Yes, sir.
Yeah? Okay. So imagine you are having a necklace, okay, with 4 beads. Okay. So if that 4 beads, you are telling the, let's say you are going to tell the jewelry shop person to arrange the beads in this specific way. Will it make any change if they are sitting in this way or in this way or this way? Will there be any difference? So will they be positioned, whatever position they are sitting, instead of imagining them as person, if they are like beads, you can imagine it clearly. That's why I'm saying this example. So if instead of A, B, C, D as a person, imagine them as a chain or a necklace. You can easily rotate the necklace. The necklace, whatever beads you have arranged, even if you are rotating, the beads are arranged in the same way. The arrangement will not change if you are rotating the necklace, right? You understand?
Sir.
Yes. So
Yes.
this part, is it clear why this 4 arrangement they are same? Is that clear?
Yes.
Okay, fine. Okay, so now we see that if you are using the usual permutation formula, now we are going to count all these 4 A, B, C, D, B, C, D, A, C, D, A, B, D, A, B, C as individual arrangements, but they are not individual arrangements, they are same. So how to fix this problem? So to fix this problem, one way is that you fix one person and then remaining 3 people around you move around. Okay, for example, here I am fixing A and the remaining 3 I am moving around. So this B, C, D, I can arrange, you know that we have 3 factorial ways, which is 6. 6 ways I can arrange B, C, D. So now you see that all these are different. You cannot just rotate and get another one here. Because A is fixed, rotation will anyway keep the... So even if you rotate, you cannot get any of the other from 1. So all these 6 are distinct, right? So these are the number of ways you can arrange the given 4 people. Now do you understand what we have done? We have fixed one and remaining we are arranging in different possible ways. So in this way, we are avoiding this repetition which we saw earlier. So what we have done, instead of considering 4, we have considered fixed 1. So, only n minus 1 is what we have considered. So, the answer number of ways is n minus 1 factorial. So, in a circular permutation, the number of n distinct objects can be arranged in a circle. Clockwise and anti-clockwise here are different, is equal to n minus 1 factorial. What is mean by clockwise and anti-clockwise are different here? So, A, B, C, D. So, consider this arrangement A, B, C, D. Right? So, this suppose I am writing as A, B, C, D. Okay. Now, I am going to look at the anti-clockwise arrangement. A, D, C, D. Are they same or different?
Different.
They are
The
different.
inverse of A are different.
So you see the first one A, B, C, D is here and A, D, B, C is here. A, D, B, C. They are different. Right? They are not same. So clockwise, if you look, the arrangement is different. Anti-clockwise, if you look, you will get a different arrangement. So the A, B, C, D or A, D, B, C. So it depends on the arrangement, how you are looking at. Right? So clockwise and anti-clockwise are not same. That is a very important factor to consider here. You will understand why it is important. Okay. So note that in this case, AD, BC and ABCD are different arrangements. These are different because nobody can obtain one arrangement from other simply by rotating the table. So clockwise and anti-clockwise are different in this case. So up to this, is it clear for everyone? Whatever doubt you have, please ask me. Don't hesitate. Okay, till now everything clear, right? Okay, shall we move on?
Ma'am, can you repeat one more time?
Which one?
Yeah, both scenario.
This circular permutation you want me to explain, right?
Yeah, it
So-
is an next.
I have not yet talked about clockwise and anti-clockwise same. That
Yeah.
scenario we have not yet seen. Only the different scenario we have seen. What is mean by different? So let's say A, B, C, D. If now I have positioned them here, right? So this is the clockwise arrangement you see below A, B, C, D. Now, if I'm going to look at the anti-clockwise direction of the same arrangement, A, D, B, C, that's not going to be the same arrangement. It is a different arrangement. A, D, B, C is going to be a different arrangement. So, clockwise and anti-clockwise, if you're seeing, if they are going to be different, then you have to remember the formula is simply n minus 1 factorial. Okay. So, and why minus 1? Because as I said, why minus 1? Because you see that all these positions are just, if you see A, B, C, D, B, C, D, A, C, D, A, B, D, A, B, C, they are actually the same. You can get the other by simply rotating, right? Rotation is not allowed here. So rotation, if you allow, then you are getting extra. So in this case, what is happening? We are fixing 1 so that no repetition is happening. So to avoid repetition, we are fixing 1 and hence that 1 is reduced from the total. So you have n minus 1 factorial. So is it clear? Shall we proceed? Yeah.
Ma'am, in previous example, why we not perform a rotation?
How we are performing rotation?
Yeah.
Okay. So
Means why we not consider a anti-clockwise and clockwise situation? Yes.
why we are not considering anti-clockwise and clockwise as same? Is that what you're asking?
Yeah.
Okay. So here, look at this arrangement starting from A. So if I'm looking at clockwise, the arrangement goes like this: A to B, B to C, C to D. This is the arrangement, right? But if I'm looking it in the anti-clockwise direction, what is the arrangement I'm getting? A to D, D to B, B to C. So the arrangement, if I have to follow this direction A, D, B, C, then it is a different arrangement. It is not same as A, B, C, D. You can clearly see these two are different, right? These two are different, right? It's very obviously it's visible that these two arrangements are different. Can you
Yeah,
see
yeah,
that they are different?
yeah, different.
Yeah. So here you see in the first one, A, B, C, D, I have considered is in a clockwise direction. But in the same figure, if I am looking at the arrangement in the anti-clockwise direction, it is not same. It is a different one. It is ADBs. So clockwise and anti-clockwise are different here. Okay. And regarding the rotation, what is happening here? Rotation means you imagine you have a photo, right? So in photos, you have the option to rotate. But if you are rotating, will the photo change or remain the same? It will change, right? Yeah.
Yeah,
So here, if you are rotating, is anything changing here?
no,
The positions, the neighbors here, mainly the arrangement of the people is what is matter. So here, even if you are rotating A, B, C, D, their positions are fixed, right? They are just still neighbors of each other. Whoever were the neighbors earlier, they are still neighbors. If you are rotating, only their
so
entire
ma'am,
position is
here,
getting shifted. Yeah.
here position will not be changed.
See, the position with respect to each other is what you have to see. Because this is arrangement, we are looking at the position with respect to each other. You understand?
No, ma'am, I didn't.
Okay. So let us say you have a red bead. So this red one, let's say is representing A. Okay. So red blue is representing B. Red, blue, green is representing C. And let's say yellow is representing D. Okay. So now imagine that this is a bead. Okay, kind of a necklace. Red. And then you have blue. And then you have green. Followed by yellow. Right? Now the same, I'm just going to the same necklace. It's just got rotated in my neck. Okay, imagine the same necklace is around my neck. It just got rotated a bit. Okay, so red got moved here. Blue got moved here. Green got shifted here. And yellow got shifted here. Now, is the necklace same or different? Tell me.
Same.
They are same. That's what I'm saying. Even if you rotate, whatever is the arrangement, that has not changed. The previous arrangement and this arrangement,
So,
they are still.
ma'am, we can say if we rotate in anti-clockwise and clockwise, so arrangement are same here in this case.
See, if you are considering it as a bead, then that is a different case. But if you are considering them as a person, A, B, C, D, what is meant by clockwise and anti-clockwise? So here, if you are looking at clockwise and anti-clockwise again, so this is A, B, C, D, right? So this anti-clockwise arrangement is this, right? And what is the anti-clockwise arrangement? It is A, B, B, C. So in that case, suppose let's say I'm going to now draw the corresponding figure A first, and then you have next is D, next is B. So this is B. So and the next one is green. Sorry. Green. So these two are the same or different? The first necklace and this one, are they same or different?
And different.
They are different, right? So clockwise and anti-clockwise. So you are now viewing people, let us say instead of beads, imagine them as the shirt color they are wearing. So you see when they are sitting in the anti-clockwise direction, you see the arrangement is different, right? So you understand the difference, right? So these two are not same. Is that clear now? These are not
Yeah,
same.
ma'am.
Yeah, but these two are same. Clear?
Yes,
Yeah.
ma'am.
Okay. So
The best, ma'am, can I tell an example?
example of what?
This circle table
This
permutation.
itself is an example, right? So people sitting around a table itself is an example. What other example you are asking?
Considering rotation, in rotation, the merry-go-round.
What kind of examples you are asking? I don't know. You can,
Ma'am,
instead of people, you can think of keeping some objects or keeping some animals. So anything instead of A, B, C, D, you can think of some other objects or animals or something one day. So maybe here, as I considered this t-shirts or beads. So this is what you can give us another example, right? So instead of 4, maybe you can consider 3, 5, 9, or any number you can consider. So what kind of example you are asking? What is that point you want to understand? Based on that, I'll try.
ma'am, I'm telling one example. I am telling one real world example for this.
That's what I'm asking. Example to understand which particular part. Based on that, I will try to give an example because I have already given example. So what is that you are expecting? I don't understand.
Yeah, maybe I can give an example.
You give necklace example, isn't it? Like that, I give one example. Is that merry-go-round? That game is the best example I am telling.
Okay. What is that you want to understand from there? I'll try to draw based on the scenario you are saying. So merry-go-round, the positions are fixed. People are sitting in different positions. So what are the different possible ways the people can sit around? Is that what you're asking?
Ma'am,
Yeah.
if we fix any one of them, so and rotate, so arrangement are different, right?
Sorry, can you please repeat?
Yes, that only I
If
am
we
telling as example for merry-go-round. Consider you are sitting in one seat in merry-go-round. In right side, the person is different. The left side, the person is different. So in clockwise, the arrangement is different, and anti-clockwise, the persons are different. That is the example.
Okay, so you are saying in a merry-go-round, if even the rotations happening, people are sitting in the same position. So that is not changing. But the
Yes,
order in the, yes, that's a very good thing to
yes, that only I'm
compare
trying
it.
to tell.
Yeah, yeah. A very good example. Thanks for sharing it here. So the person who asked this example, do you understand what is he trying to say? This example, is that clear?
sorry, ma'am, can you repeat?
So what is meant by merry-go-round? That do you know? So in um what kind of this kind of places where you have this fun games and all, you have something called this merry-go-round, right? So in amusement parks or something, so you have this kind of a merry-go-round, right? So what is a merry-go-round? I don't know really how to draw a merry-go-round, but just something I'm drawing. Okay, so imagine it's something like this, or even a giant wheel you can imagine. Okay, so you have different positions here, right? So these are seats. Okay, so each of this is a seat. Okay, so imagine as a merry-go-round or a giant wheel or whatever, right? So inside this, people are sitting. Right? So now, when this entire thing rotates, are the people's position changing or they are sitting in the same positions?
Sitting on the same
Same.
position.
Yeah. So that is what we have said in the first part, right? So in the first part, that's what we are saying. Even if we are rotating, the positions are not changing, the arrangements are still exactly the same. So the first part with this example, is it clear for you now? The first part? Yes?
Yeah. Yeah.
Okay. Now the second part is about the clockwise and anti-clockwise. So now this is one arrangement. Now consider the other arrangement, which is this. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So now the other arrangement is this. So here I am having the same giant wheel or merry-go-round. Now I am having, so this is P1. Now I am going to write the anti-clockwise direction, whatever is here, that I am going to arrange it here. So P8, P7, P6, P5, P4, P3, P2. So you see, this is the clockwise and the same thing arranged in a anti-clockwise. So now you say whether these the people are positioned in the same way or they are arranged in a different way in these two. The arrangement is same or different. So this person, for example, P1, earlier in this positioning, on the left hand side, the person was P2 and on the right hand side, the person was P9. But now in this arrangement, you see the left hand side person is P9 and right hand side is P2. The positions have changed. So these two are different arrangements. Can you understand this part now?
Yeah.
Yeah. So now is
Yeah.
this comparison clear?
Yeah. Yeah. Clear.
Yeah. Okay, good. Okay. Okay. What about the next part where clockwise and anti-clockwise are same? So now the same red, blue, green, yellow bead, we are going to consider it. Okay. So we did not imagine flipping the necklace. That part we did not consider. So can we flip these people around? So flipping means turning them over completely. So that we cannot do for people, right? So something like flipping, whatever you can imagine. What is meant by flipping here? You understand, right? Flipping, let's say flipping roti. You understand what is meant by flipping? So on the tawa, you flip it completely. So what is meant by flip? Do you understand? Okay.
Yes,
So
Yes.
so you can flip a necklace. You cannot flip people like that, right? So you can flip a bead like this. So for example, this bead itself, this red, blue, green, yellow. So this, let's say you are having this flip. So this is red, blue, green, yellow. So now you are flipping it over. If you are flipping it over, okay, so you have flipped it over, what will happen to their position? So this is red,
left becomes right, right becomes left.
blue comes on the other side, right?
Yes, ma'am.
And yellow comes to the opposite side. And green stays. So flipping the bead, this is what happens. So this is what happens when you are flip. So now look at the arrangements. So this is red, blue, green, yellow. This is red, yellow, green, blue. So this is whatever is in clockwise is same as the anti-clockwise. So from red, so from red here, this is clockwise. And what is there in the anti-clockwise if you consider? In the anti-clockwise, you see maybe a different color. Yeah. So anti-clockwise red, yellow, green, and blue. Red, yellow, green and blue. So now in this case, your red, blue, green, yellow and red, yellow, green, blue are same because you can flip them over to obtain the other one. So in this case, clockwise and anti-clockwise are same. So do you understand how they are same? Because if you flip them over, you get the anti-clockwise. So clockwise and anti-clockwise are not different now. Do you understand this clearly? Yes or no?
So the objects which we can flip it has clockwise and anti-clockwise are same, isn't it?
Sorry, can you please repeat your question?
The objects which we can flip has this clockwise and anti-clockwise are same, isn't it?
Exactly.
Okay.
Okay. So even flipping does not change the what to say. So suppose these are beads, they are circular objects. Flipping means the objects are still remaining the same. So nothing is changing when you are flipping. The necklace is still the necklace only, right? But if flipping changes them into something different, then flipping is not valid there. So flipping should keep the object as the same object. Okay, that is what is meant by valid flip. Okay, so in this case, here you see that now what is happening? Anti-clockwise and clockwise are now same. It means earlier we have counted them twice, right? So now to remove this counting happening twice, what is it we have to do? Can you tell? What is it we need to do? Now
Divided
flip
by
it.
2.
Divided by 2, that's it.
Factorial.
Right?
Yeah.
We just have to divide by 2 because it's just happening twice. It's counted twice, right? So since it is counted twice, we are simply dividing the formula n minus 1 factorial by 2. Clear? Okay. So what are the things we have seen so far? So first, very basic principles of counting. Then we saw factorials and permutations when objects are distinct. In that, where repetitions are allowed and repetitions are not allowed. Both this scenario we have seen. And then when objects are not distinct, so that was the case where we considered data, statistics, the rearrangement of those words. So that is what we considered here, right? And then we saw what are circular permutations. In circular permutations, we saw when clockwise and anti-clockwise are different. And we also saw when clockwise and anti-clockwise are same. These are the different concepts we have seen. So the last part is solving for R and N using some permutation formula. So this is something which you are going to try it yourself. I'm going to give you the questions. You all take your paper and pen. We are going to solve these questions because this is just purely application of formulas. So everyone take your paper and pen, try to simplify them and figure out the values of N or R based on the questions. Use the formula, whatever formula you know, use those formulas here and find the value of N. Can you all try?
Yes, ma'am.
And n is equal to 7.
N is equal to
7.
Okay, fine. Let's see how. So what is the left hand side here? NP4. NP4 means n factorial by n minus 4 factorial. And on the right hand side, it is 20 times n factorial by n minus 2 factorial. Right? On both sides, we can cancel out n factorial. Right? And then in the next step, what we can do? The next step, here you have n minus 4 factorial and here you have n minus 2 factorial. So let's move them this way, right? So now this n minus 2 factorial, I can write it as n minus 2 into n minus 3 into n minus 4 factorial. Do you all understand how I am writing this n minus 2 factorial in this way? We have earlier seen one formula, right? What was that formula? So if you have n factorial, you can write it as n into n minus 1 into n minus I plus 1. Like that you can write, you remember, right? So here that is what we have done. So here n minus I factorial. That is what we have done here. Okay. Is that clear? What we have done here, is that clear? Yeah. So here n minus 2, n minus 3, n minus 4. Okay. So here in this case, your first n itself is n minus 2. So for example, if you are taking k is n minus 2, this is k minus 1, this is k minus 2. So this step, is this clear for everyone? Yes or no?
Yeah, ma'am.
Okay, fine.
Please explain it again, ma'am, why we are taking n minus 2 factorial as n minus 2, n minus 3, and till only n minus 4.
Because here n minus 4 factorial is there. I want to cancel it out. I want to have the same term so that I can cancel it out. That's why I stopped it here. You understand the purpose of rewriting it this way?
Yes, ma'am.
Okay. So now I am going to simply cancel it out. So these two terms I can cancel them again. So after cancelling, what will I have? So in the left hand side, I have n minus 2 into n minus 3, which is n squared minus 5n plus 6. And then here I have 20. So again, I can rewrite them. So n square minus 5n plus 6 minus 20. So I have n square minus 5n minus 14 equal to 0. So can you solve this quadratic equation? What are the roots of this equation?
7 and minus 2.
7 and minus 2, right? So you have n equal to 7 or n equal to minus 2. So this is not possible for permutation. So n equal to 7 is the right answer. Is this clear for everyone? Yes or no?
Yes, ma'am.
Ma'am,
No.
what is
Yeah,
k then?
ma'am.
What if?
K?
Sorry?
Ma'am, k.
Okay. Oh, just for you to understand, I have written here. See how I have applied this formula n factorial equal to n into n minus 1 into n minus I. So here the starting value itself is n minus 2. So just for you to understand the same formula I have applied here, I have written n minus 2 as k. So the next step is k minus 1 and the next step is k minus 2. So just for you to understand, I have written. So if you don't want, I can remove this. This is not required.
Okay, thank you.
Okay, so let's try the next question. Find n if np4 by n minus 1 p4 is equal to 5 by 3.
10.
Ma'am, I think n should be 10.
Okay, let's see how 10. So here you have n factorial by n minus 4 factorial divided by n minus 1 factorial by n minus 1 minus 4 factorial is equal to 5 by 3. Now, the numerator n factorial is there. You can, first of all, let's write it in this way so that it's easier for computations. So I'm going to bring this part. This part, I'm just bringing it here. Okay. So n minus 1 factorial by n minus 5 factorial. Now I can write n factorial as n minus 1 factorial, n into n minus 1 factorial, right? And you have n minus 4 factorial, which you can write as n minus 4 into n minus 5 factorial, right? And this is equal to 5 by 3, n minus 1 factorial by n minus 5 factorial. So again, you can cancel out these terms. So if you cancel out these terms, what is going to be remaining? N by n minus 4, which is 5 by 3. So you have 3n equal to 5n minus 20. So 2n equal to 20, which means n equal to 10. Is this clear? How we did this, is this clear?
Yeah.
Is there any step where you have any questions? Okay, fine. So one last question. Yeah? Yeah, what's the question? Find R if 5PR equal to 2 times of 6PR minus 1. So this time you have to find R. Similar techniques only you have to use, nothing new.
Excuse me, ma'am.
Yes?
Ma'am, I have some doubt related to this chapter, but not related to this topic. When can I ask?
Related to what?
I'm related to permutation and combination only, but not this topic particularly.
So we are having the doubt session on Friday. You can ask at that time.
Okay, ma'am.
Yeah. What's the answer?
It should be 3.
R equal to 3.
Correct. Correct. So again, so how 3? So directly applying formulas. So R minus 1. So minus into minus becomes plus. So again, we can rewrite it. So 5 factorial by, so this becomes 7 minus R factorial, right? So 5 minus R factorial equal to 2 times of 6 into 5 factorial. And then you have 7 minus R factorial, right? And this 7 minus R factorial, how can you write? So this one, you can first of all cancel out these two terms. And then you have 1 by 5 minus R factorial, which is equal to 12 by 7 minus R factorial. How can I write?
7 minus R into 6 minus R.
7 minus R, 6 minus R, to 5 minus R factorial. right? So again, here you can cancel out these terms. So what will be remaining? So 7 minus r into 6 minus r equal to 12. Okay, so you have r square minus 13r plus 42 equal to 12. So r square minus 13r plus 42 minus 12 equal to 0. So r square minus 13r plus 30 equal to 0. So what are the roots? R minus 10 into r minus 3 equal to 0. So you have r equal to 10 or r equal to 3. So in this case, in your question, n is equal to 5, right? So if n is equal to 5 for r, your r should be less than n, right? So less than or equal to n. So in this case, this is not possible. So this is the only correct answer. So is this clear? This is just application of formula only, nothing new. So far everything clear for everyone? Okay, so we have
Yeah.
covered the topics of week 5 in today's session. And whatever doubts you are having, please go through the lecture content, solve all the activity questions, practice assignment and GA. And on Friday, we will discuss whatever doubts you are having in these topics. We will discuss them on Friday. Okay?
Okay.
So in general, my sessions, are you finding it comfortable, or are there places where you think you can, I can do it differently? If you are feeling that, please let me know, because already quiz 1 is over. By now, you will be able to analyze whether the sessions are useful or not, right? So if you have any comments, it's really high time to say, so that I can incorporate in my upcoming sessions. So are there any such specific comments where you can suggest me that, okay, so this particular part, maybe you can do it in this way so that it will be easier for us, something like that? Is there anything like that? Any suggestions?
No, ma'am.
No, ma'am, everything perfect.
Okay, so fine. Thank you.
Yes, ma'am.
Okay then, so see you again on Friday then. Thank you all.
Thank you, ma'am.
Thank you, ma'am. Good night.
Thank you.